Oh, okay. Almost half of the auditory. Nice, nice. Okay, so here we have Radoslav, and Radoslav will tell us what is it and what is his experience about GraphQL and how to use it. Okay, Radoslav, I wish you good luck.
So,
Let's start.
howdy. So yeah, my name is Radoslav Stankov. I come from Bulgaria. Like just some technical information, all the slides are already on speaker deck with all the links I'm referenced, so you don't have to play that game with me because I'm tend to changing slides quite fast and people like cannot catch on. So this will be the last slide of the presentation. So this will be the URL, so you can enjoy the slides at home if you liked. So I work at a company called Product. It's a startup from San Francisco. And this is like we work on this website. And recently this year, like in February, we started integrating GraphQL, and now most of our traffic passes through GraphQL. Our whole front end is GraphQL. So today I'm just going to tell you how some of the challenges we had in the front end stack and how we solved them, and most probably how we handle the problems, like what was our mindset of solving some of the problems we encountered with Apple and with GraphQL. So just about a bit of context, since context is king. Like the way Product Hunt works in the backend is we are still hosted on Heroku, and when the request comes, we have a Heroku dyno where we have three things living. One is an Nginx, the other is an Node.js server for React, and one is a GraphQL server written in Rails. So when the browser requests an HTML page, a normal one, it gets routed to the Node.js app. It does React server-side rendering, calls the Rails GraphQL API, and renders the whole page. Afterward, if the browser, when the page is already loaded, needs some other information, it just goes directly to Rails. So in this way, we can scale. So this is like the front-end conference, so us focus mostly on our JavaScript backend, front-end stuff. And if you care about GraphQL in Rails backend, you can just find me. I'll be walking around. So yeah, so we are using GraphQL, and the best way I found to like show GraphQL is just not to start explaining like theory and all that stuff, but just show you. So as I told you, this was the Product Hunt website, and like this page is totally GraphQL powered. And let's see how we can actually build this page. But for the sake of time, I'll actually build this small piece of the page, and the rest of it is quite similar. So usually when we start building stuff, it's great to actually focus small. Like let's focus on how to build this one piece of information. And this thing is called a topic. It has an ID, it has a name, it has a description, it has a flag if the current user is following that topic or not, and it has like an image. So this is the information which we need to display this single item. And this is, you can think of that like a JSON template. Like this is the way you would describe a data when you want to give it to somebody. And that's actually GraphQL. Like this is a valid GraphQL. We just need a bit of syntax to say this is a query, so we want the data. And we say, okay, I want the topic, and in our case, I need the topic by ID 1, just to show that item. And with GraphQL, you are hitting, okay, this is not very visible, but there is a URL here. So you are hitting an endpoint with this query, with this JSON template, and on the backend just returns you the same data. Like just fill up the blanks and make it a valid JSON. So for our line item, we can just request this, get this data, and be happy about it. And this is how the query looks, this is how our component looks. So let's see how this component looks with React. If we look at the React structure, you can imagine we have something like this. We have a topic item, we have a topic image, we have a name, description, topic, follow button, and so on. So if we look at the query, there are some fields which are not presented in this piece of data. And the reason is here that the topic image actually requires the image. I guess is followed is required by the topic follow button. The name and the description are obvious here. So if we build our query by just for this component, and at some point in the future I start changing my topic follow. For example, the topic follow button, we want to have this nice effect when you hover the button, we show you a nice text of you follow blah blah technology topic. And then we would need the name, but if we don't show the name anywhere else, we actually have to this explicit knowledge, and we actually don't care about that. So GraphQL has a feature which is called fragments, which gets this really nice tiny query and splits it into something like this. And this looks very messy in the beginning, but let me just focus these pieces. So the topic image, what does a topic image need? It needs an image. That's it. It's the topic image component. We create a fragment. You can think of the fragment as a JavaScript object which you can spread across like a query, and you can nest those. So we say the topic image requires the image. Not surprisingly. The topic follow button is followed. Oh, and surprisingly, it needs the ID, because when we click the button, we have to know what's the ID of the post we have to follow. Also, it needs the name for some reason. We don't know what's the reason, but there should be one. And we as developers shouldn't care, like it's somebody else's button. And the topic item itself, it needs the ID just for page indentation or something like that. It needs the name and the description, obviously, but then it ejects the fragments from the previous components, because it doesn't care what those components' data requirements are. It just cares that it needs the data they need. So it just think about this like a JavaScript spread operator. It just spreads the fields and injects them here. And then for getting our topic, we just spread the topic item component. And this query gives you the same result. Like you can have like 1,000,000 fragments, and in the end, they're flattened out in the server. And in this way, you build the practice here is you build a fragment for every component, and then you start nesting them. So most components know only about what fields do I need and which components I need to render, which is very obvious when we look at the code. So that's cool. That works great. Like this is how we get our topic item. We get it, and showing one topic item is cool. But let's go back again to the big picture. The big picture in our case is we want to render the whole list of topics. So what changes we have to make here? So the query here will be very similar. It's actually we're just changing, instead of getting a topic by ID, we just say give me all topics. And the rest of the code is same. GraphQL is smart enough to know that if this thing returns an array, it gives you a list of topics. And this is how like pretty much you work with GraphQL fetching data. You build fragments, you group them together into a query, and you use that. How do you connect this to the front end? Like querying is cool, you can do stuff, but if we don't actually connect, how do we connect them with the component? So for connecting, we use a library called Apollo or Apollo. I never cannot pronounce the name. There was a spaceship named that way some time ago. So we use this library. So how do we use it? So if we go back to our example, this is our directory structure. I really like presenting directory structures. And this is how all the stuff you need are. We split the component into two pieces at Product Hunt. One is called components, which contains every type of reusable component, something which will be used in more places. And we have pages, which is like a page. So if we see the topic follow button, we use this React pattern. It's called folder pattern or something like that, where your React component is not a single file, but a directory. It looks like a package. And in this package, you have an index.js, which is like the component you care about. We move the styles inside of that directory as well. If you have any assets to that component, it also goes there. If you have some subcomponents, they go there. And we have these GraphQL fragment files, those ones. So those GraphQL fragment files are, actually there's a path here, but it's not very visible, but this is the fragment file. The fragment file is just the GraphQL query we already saw, but it's in the folder where the button is. because they're tied together. Only the button knows about the exact fields it cares about. So this is the topic image. Topic image, just as we said, we need an image. For the topic follow button file, we need the ID, the name, and is followed. The topic item GraphQL query is a bit more complicated. What it does is exactly the same fragment, but we actually need to have this import statement in these GraphQL files. So Apple gives you a way to import those GraphQL files inside of each other and have a say in life by not mixing them together in bad ways. So you actually build your topic item the same way I showed you before, just you import the fragments before. And the nice thing is if you actually rename the component or move it somewhere else, your Webpack build will break, and it will told you, yeah, you have to move those files as well. So you reduce the number of runtime what the fucks, right? So let's go to the page itself. So the way we name all the fragments because they're easy to search. And also if we name the fragment, we don't want to rename the files. We have the same convention for pages. The pages have queries, which is a GraphQL query file. And again, they have index and styles, and the GraphQL query file is actually where the query lives. Like everything else is a fragment, it's called a fragment, and the queries are the one where we make the query itself. So here we import the topic item fragment to get all the topics, we get them. And the nice thing is here that this thing would import the other file, so we get something like this. Topic page knows it has to render topic item. The topic item itself gets the data for topic image, topic follow button, and all this gets bulked together. And in our cases, we actually have hierarchy, which if I showed you, it will get somewhere around there to the coffee area. And yeah, that works quite well. Like you just nest and you have runtime checks if, for example, every fragment is valid. If you, for example, rename the field from name to title, your Webpack would blow up, and you would know, okay, I have to fix that. So this is how we just define the fragment. So how do we use them in the React itself? So this is the topic index itself. It imports the topic item. It imports this query object from our files. And it copies this high order function from Apollo. This is how, finally, when we see the word Apollo somewhere. And this high order component just gets a query, and very similar to the way Redux and all the other like high order components work, it accepts a content, and then it passes him a props. So the query is a serialized object of our query. It gets passed through GraphQL. So when this component gets inserted into the DOM tree, the query is made, or it checks in some internal caches if it's already made. And then in the component yourself, you get the data. And this is the end, you have our topics. This is the data you want to load. And you get this field loading, because, I mean, this data doesn't come instantly. Like, as much as I want everything to be instant, we have a loading, and we have to show a loading indicator. So our component looks like this. We get all the topics. We show a loading, usually a spinner, but this time it's short to just show a loading text. We show topics, we just map over the topics, and we show the topic items. And it's quite simple, like very simple way. And we started using this pattern, and we noticed that we were doing this thing too much. Like we had too much time, we do loading, if loading, and it's quite boring. And sometimes people forget it because their machines are fast, and locally everything is instantaneous, and when they ship, when we see some exceptions in production, and it's bad. So in order not to forget the loading, we extracted a high order component called with loading. So we had this nesting that we get the GraphQL component, then we add the with loading, so we don't write much code. Like my goal in life is to write less code, and that's the reason we extract stuff like that. And that's cool, but if you start looking at it, it's kind of like which is first, which is last. So we used another feature from Apollo, which is called compose. It's a utility function. It's like this utility function compose in React world. I think like 10 libraries has the same function implemented in the same way. So what compose does is pretty much that. It gets you higher order components, it nests them, so it generates a single higher order component which contains all of those, and you can have your content. So since we use a lot of decorators, this is quite a nice pattern. So you read it, you see, okay, we get the GraphQL query, we show loading text, and then we show the content. It's quite readable. And yeah, that's pretty much it. This is how we get to our page. And we were using these patterns. They were nice, they worked well, they were fun to use, but we needed to have like pagination here. Like I wanted for us to have like 5 topics and to be easy, just show the 5 topics and be happy. And then we had like 200, 300, and it's like, if you load all of them, it's quite slow. So we started looking for a way to do pagination. How do you do pagination in GraphQL since it's like a new technology? And the only answer came from a library from Facebook, which is called Relay, which actually contains of 2 things. So Relay actually is 2 things. The first thing is a library like Apple, like the first GraphQL library, very comparable to Apple. It has some choices we didn't like back then, and we didn't use it. But what we used from the Relay was, it has a Relay specification. The Relay specification is a way for you, like 3 rules, how you should design your schema, how you should make your schema better. And their decision mostly are because Relay uses it for internal caching and some nice things, but all of those 3 ideas are quite cool. So the first idea is called the node interface. Since GraphQL works with graphs, we have connections and we have nodes, like some graphic terminology. So the idea of node is, we have this topic and it has an ID, but I can bet in your systems, like if you have topics and they have ID and they have ID1, I bet you have user with ID1, which is most probably the founder or the first developer. You have something else with ID1, and you cannot use this ID to uniquely identify objects in the graph, because if you want to have a cool graph, you should be able to point to any node in that graph to find it quite quickly. So what Relay says for the node interface is, yeah, you can have IDs or other identifiers, but they have to be unique across your whole schema. The idea for that is so you can find every object in your database by just one ID. So that sounds cool. And the simplest way to do that is to use base64 with the class name plus the ID. So this would generate a unique identifier. Like you can use the string topic ID1, but it doesn't look so cool. When you base64 it, it looks quite cool. Like it looks like that. Like you see, yeah, we are using something really mature, but in most of the libraries you use base64, or if you use a database storage which supports unique IDs, you can use that. But what we do is base64. So in this way, all our topics are unique with their ID. All the users are unique with ID. So we can change finding them with this simple node interface. That's actually the node interface. You have a way to find every node in your system, every object in your system. The reason Relay have that, and we are starting to use that, is caching. The idea is, I have a data for some object. I don't want to load the whole object again. I just want to load 5 fields from that object. And that's not part of my effects, but it's a cool effect. Yeah. So I have that, and it starts to shake because it's so cool. And the thing about it is, you can find uniquely your object. So you can do stuff like that. Find a node ID with a topic. If the field which returned is a topic, because this actually doesn't know what it can return. So you say, if this is a topic, return me a name. The good thing is you can say, if it's a user, return me the full name. If this is something else, return me something else. So you have a single place to cache in, cache out data. And yeah, it's quite useful. I don't have any examples for that, but it's an intro to the schema. So let's go to the original topic. I think I got a bit off-road. So the other part of the graphs, so in the graphs you have nodes and you have connections. So Relay has some opinionation about how you define your connections. And the idea for connection is because you need to do pagination. Like you cannot show all the data you have. Like imagine you are Facebook, load all people's friends into a single page. That would, like, I don't think they even have it in a single database. So the idea is these all topics returning only an array doesn't work. So you have this connection. So the idea of the connection is you have cursors and before and after. So it's designed for infinite scrolling pagination, but you can actually use it for a number base where you have page 1, page 2, page 3, page 4. You just calculate what's the cursor there. The cursor can be anything. The cursor can be 5 or the ID of the previous record. So the idea is you have this structure. Also, it's designed to work backwards. So first and after is if you have loaded data, then you load that after, that after, that after. Also, you can have data here and load the data before it. So imagine you're Facebook, you have to be the news feed. You're in your noon feed item, and you start scrolling up, you have to be able to go back. And that's pretty much what the node interface is. You have a connection name, which is like what's the thing you're showing. You always have edges, which are the things you want to load. Each edge has a cursor. The cursor can either be its ID, or it can be the page number, or the number in the whole lineup, or something like that. The node, again, you see the node interface here is an item. An item doesn't have to follow the node interface, but it's used to have it. So this is actually the data you care about. And you have a candy object which is called page info, where you can see, okay, this is the end cursor in my line. This is the first cursor. Do I have a next page? Do I have a previous page? Also, this is the junk drawer for how many pages I have, how many the total items I have. It's like a nice place to put page-related information. So yeah, that's for our page. So our page have to be like this, infinite scrolling, because it's like modern and it's like less friction to the user. So you can scroll up, down, and all that cool stuff. So how do we implementing that? So implementing that is quite simple. We have, this is our old query, and we make it this really big new query where we first, let's not start with the whole pagination, let's just start with the first 10 items. Let's just load the first 10 items. So it's quite obvious. We say, give me all topics, the first 10 only, give me the topic item, and tell me, is there a new page? Is there a next page? And I'm loading everything. So this was our query before. The only thing we need to change now is move these all topic variables to here, and we say data, give me all topics, give me the edges, and map those edges to nodes. Like, you have to write this every time, and I'm lazy, I don't want to write. So you just extract it to a function, like a simple function where you give it a connection and it just gives you all the nodes, because for showing stuff in the list, you don't care about anything else. And because this is JavaScript, you have to have checks, because who knows who is passing what from where, and also where data is loading. So you have this, you put it in like an utils folder where you have like a bunch of those GraphQL related functions which convert your data in some cool ways. And we have this, now it's quite more readable. We get all the topics from extracted edge nodes. It's so cool that you can actually inline it and we don't have any variables again, which is cool because less variables, well, less things to break. And yeah, this is our query. The query is cool, but we only show the first 10 items. In order to show more stuff, we need to have something else, like we need to load more. So in order to know what's next, we use the cursor. And the way we use it is we're just passing by a variable. This is how you can pass variables from your front end to the GraphQL query. You say this is a cursor, it's a string, can be null. You say load me data after this cursor, and you get this interesting end cursor property. So when you load your page, you know what's the last cursor, so you can just reuse that. So that's cool. How much code does it is? So this is how it looks code-wise. It's kind of messy, but let's read through it. Like, you would suffer it. Oops, sorry. So yeah, you have this has next page. Check in the top you have we have a custom component infinite scrolling. We haven't open sourced it because it's very custom to our loading animation behaviors and we are lazy, me especially. So we just have this infinite scrolling. It has some scroll function which says, okay, load more, which is like a callback. And it loads until it has like a next page, which is like this Boolean query. And in the compose, we have this load more function, like in the GraphQL, you can remap and you do this pagination. And when I implemented this, my colleagues were like that, like very terrified. And I'm like, yeah, you should do that. This is not my colleagues, this is some other people on the internet, like Corey Haynes and Eric Patterson. So yeah, but my colleagues look like this when I show them. And this is like a common pattern if you work with Apollo. It's like IKEA, you just have to build something and they just give you a manual and you have to build all those tools on top of it and handle it in some funny ways. And yeah, so what we start doing is, okay, how I can make this better? Like this looks disgusting. So the first thing when I want to make some code better is I just turn off highlighting and I just see what's the unique part here. Like if we see this query, you see the unique part is this data, this fetch more which comes from Apollo. So this is something we need. Also, the only unique thing is the all topics. This is like the field we want to get the connection from. So if I move this to a variable, let's say a path, because it's like a path because it can be nested, I can actually move it into this way. I can say, okay, this is a function which gets a path. It calls all more, and then this all path, everything here depends either on data or on path, and that's cool because I can actually extract it. I can extract a load more function builder. This thing can just return me a new function. It looks terrible, but it will be hidden in the interface, so only I can look at it and be unhappy about it. But it works. Like you just. And here, when you want to load a page, you just say load more, build me a new load more function, gets the data for all topics. And this thing is all hidden out. And this is how our page looks like. It still, again, nicely fits on a single slide. It's readable, we are happy, everything looks cool. And we see this load more. We see how it looks 4 times. And the only reason is we call it here, it builds something here, gets something here, comes something here, gets something here. Something it's a mess here. Like, why do we have this step? So what I actually did is, I'm just passing the data here, the connection path here, and the infinite scrolling is actually the GraphQL specific part. All the stuff, extracting the edges, getting the load more, gets hidden into like a single component. And right now it's quite cool because you just have to use this component, you just pass it data, you say what you want to paginate and it paginates. And this is the way to think about like how to deal with Apollo. You just look at what you can extract and build more abstractions on top of it, like an IKEA. And in the end you wanted to have like a chair and you get a table. But it's a cool table. So yeah, that's cool. So we pretty much built that part out and we are happy. Like, this page works, it's great. But if our goal was only to display data, we would be more like Haskell developers. And we never mutate stuff. And in GraphQL, we need to change data. Like we have to update, for example, how does the follow button going to work? So in GraphQL, the way you change data is through something called mutation. The idea of a mutation is you mutate data. And relay specification, as for everything in mains, they have a mutation specification, how they make mutations work, like what mutation follows the relay specification. So let's build the follow button. What's the mutation for our follow button? I want to follow games. So mutation look quite similar like the query. You say this is a normal mutation where you say, okay, follow a topic with some ID, call this mutation in my backend, think about an RPC call or a RESTful point or something like that. So you have an ID, you get this follow topic, you get the ID, and you get the follow back. So because you want to know, is the following successful? So when you call this, the server will return you the ID of the object, so you can clear up your cache internally and back home, and it's followed. So you actually know that it's actually passed. And that's nice, that works cool. This is how the unfollow thing is going to work. Pretty much the same, because follow and unfollow are quite similar operations. But this is like a very simple operation. And what happens if, for example, when you click the follow button, I actually want to know when is this button clicked? Like, is this button clicked on the topic page? Is it clicked on some other page? Is this come from another page? Because like we need to track, we need to know where people are using our features. And then we start adding like arguments. So you start adding, like you can add an ID, an A, B, C, and you can pretty much go far with mutation arguments. And this is like for simple like a topic follow. Imagine having form with 20 fields or 30 fields, which would be terrible, but sometimes it's required. And you have this long query going over there. So that's the reason Relay said all mutation get one argument. And this argument is an input. And this input is just a JavaScript object. You define its structure, it's typed, but it's the back of all required parameters for your mutation. So when, for example, I want to add a new field, I don't have to go back here, add a new field here, add it here, and remember that. I just add it and I don't change the mutation. So they have this way of like using the mutations. They have that input field, and they also have this thing called client mutation ID, which is only used by Relay for their internal like backend stuff. But we just keep it because why not? They always know we don't care. So yeah, you always return 0 for that client mutation ID. You return a topic object, so you can actually nest all the topic fields you care about, because maybe you have like a name. Maybe the topic name changes when you click follow button. It will be a cool feature. So this is how a simple mutation would going to look like. You just pass some inputs, and client ID, this is part of the GraphQL Relay specification. Like if you don't care about client mutation, you can cut it. And this is our button. Again, this is our component. This is in the topic follow button file, the follow topic. We create a follow topic GraphQL file where this is the mutation itself. We name the mutation with the name, so it's easy searchable, because mutations are kind of like destructive operations, so it should be easier to find out. So you have, in this file, we have the follow topic, here we have the unfollow topic, and this is how it's going to be used. We have like a follow button, and in our compose function, we create our own custom follow topic function, which comes from Relay has, Apple actually has this mutate function where you can just call your query and pass it parameters, like in our case, input variables IDs. And also Apple supports an optimistic response. The idea of the optimistic response is when you click a button follow, you don't want to go to the server do the following, the server returns everything is okay. You want the button to be clicked, and the user should always see that it's followed. If the server returns an error, you handle it in the background and hope that this is a very rare error. But usually you provide an optimistic response. This is what you think the server is going to return. And when the server returns something else, it replaces it. So your UI can follow that. And our buttons is quite simple. We get two functions because we have create and remove. We check if topic is followed, so we show the two buttons. Okay, so this is a small extension we actually made on the GraphQL specification. So all our mutations were following the Relay mutation specification, but we actually decided that why should we call this topic? Why don't we just call it node? Why all of our mutations don't return something named node? Because everything else uses like the node terminology. And also, if all mutations returns a field called node, we can actually build some really cool tools in the backend to fix that. So this is like a product hunt extension. Just always name this field node. And for the final, like again, as much as a web front-end developer is going to live a happy life, there is this point you have to build a form. Like this is like the moment you have to build a web form. And like with GraphQL, like with relay specification, it's not actually so bad. Like this is like a normal, simple form where you have name, headline, some email, like a drop down, you have some more complex header, and you have like an update button. So this is how the GraphQL mutation is going to look like. See how simple it is. It's, again, just an input with all the fields we needed for that form. Like, also, you have, when this form gets submitted, you return a note, again, quite standardized, and you input the fragment of the setting itself, because you would need one query to get the initial data of that settings form and the back data for the settings form. And this is how settings page is going to look like. You just have like a form helper, you have some fields, you have a button, and you say, okay, when I submit, like this is my initial data, it's coming, it's overpopulate stuff, you have a submit, and here you just have on submit, and you have what do you do when the submit is successful. And this is cool, that works great. And here is like the second extension we actually did here, is we need to do validation. Like client-side validation is cool, it's hard to do, almost never works like you expect, but it's cool. But the problem is it's only cool, it's not security, it's more usability. If you like, you should always have a backend, secure backend validation as well. And the GraphQL specification don't specify a way, like the relay, and most people don't have like an opinion how to handle errors from the server side. Like most advices use the GraphQL native errors. GraphQL supports like throwing errors, but the problem is there more for errors like, okay, the client give me a field which I don't know how to resolve, and not the client give me a wrong email. So what we did is we added a new field here. Since we already have a node and we already have our own version, we say, okay, this is errors, and the errors is just an array of a field name with an array of like strings which represents the errors, where we can encode the errors like missing, and then in the front end we can internationalize it. So this is again another small extension we did. Since our forms, when we submit data, we always check that response have a note and errors, and we check, okay, if the server returns errors, okay, just mark all those fields as error prompt and display it to me. So yeah, so that was pretty much what I wanted to talk about today. So I told you like how we design our GraphQL stuff, how we do Apple, and how we tie it to the whole ecosystem. We walked through the relay specification, just the specification, not the library. I showed you some use cases about data fetching, pagination, mutations, forms. And yeah, that's pretty much my whole presentation.
Yeah.
Thank you.
Yeah, guys. So okay, I have a few questions. Yeah, who think that he will use GraphQL on his next project? Please. Sure. Okay, and who thinks like, holy cow, what was that? I didn't understand nothing. Okay, thank you, Ivan. I know it. Yeah. Now, do someone have questions? Yeah. Okay. At least one. Let's.
Okay, thank you for your speech. And maybe I something missing, but you say about your thank you about your quality mutation. And
yeah.
What about quantity? When you insert something in your start of your list, how you observe it?
Yeah, so the way mutations work is, give me a second.
Yeah, your previous extracted results.
Yeah, so the idea is when this mutate function, it returns a promise. Mm-hmm. So if, for example, we want to add something to a list, like you have a to-do app, you enter a text and you want it. The way to do it right now, like, is you have this mutate thing, it returns the promise, and when this promise resolves, you get like from the server the new item in your list, and you have to manually add it to the way you store data. Like, for example, we use Redux with GraphQL, so we just manually update the stores.
Okay,
like,
so So it's normal situation to insert the some items in the start of list, and
Yeah.
you can. Okay, thank you.
You're welcome.
Thank you for your question. More questions? Guys, no one needs WebStorm license? Yeah? Okay, so Radoslav, you need to choose a question. Oh, okay, nice.
Thanks. So how do you connect the database? What's your stack? What's your database? Are you connecting it directly or through the API?
So this was a very good chance for us to, like, our database is kind of a messy because it's like multiple product iterations. So we actually don't want to expose our schema, don't look anything like our database looks like. So in the backend we use Rails, and in GraphQL backend you have this thing called resolvers, which resolves fields and data, and we have logic there. So our GraphQL for the internal world is this good-looking schema which makes sense for the front end, and for the back end is this database which makes sense for data storage and analytics and all that other stuff.
Thanks.
Yeah, okay. 3, 2, 1. Now you really have chance.
Yeah, I mean, the first question.
To girl?
Yeah.
Yeah?
Yeah.
Okay. Sorry, Slobodan. You tried. Yeah, guys, and we have a coffee break for, let it be 15 minutes, and then